In this presentation, we are going to introduce the 16th century Tapia on the Hispaniola island. Case: Hospital San Nicolás de Bari. The research has been developed by Esteban Prieto, Virginia Flores, Sagrario Martínez, Gloria Pérez, and Letzai Ruiz from Universidad Nacional Pedro Henríquez Ureña, Pontificia Universidad Católica Madre y Maestra, located in Santo Domingo, Dominican Republic, and Instituto de Estructura de la Materia and Instituto de Ciencias de la Construcción Eduardo Torroja from Spain. This presentation is structured with an introduction, the objective, the methodology, results and discussions, and conclusions. Since ancient times, earth has been used as a building material to make walls, bricks, adobe, or tapia, among other products. Tapia, tapial, or rammed earth is a very ancient earth construction technique that consists of compacting certain soils into a box-shaped mold. Although this technique was common in Europe, it was unknown to America, and it was the Spaniards who introduced it to the West Indies. In 1503, the walls of the Hospital San Nicolás de Bari, first hospital in the West Indies, were built with tapia, rammed earth, but until now. Tapia, or rammed earth wall, is composed by several large dimension blocks made by compacting moistened earth inside a formwork, which constitute a key element within the definition of this technique. The formwork rests directly on the wall. It is moved horizontally after each block is completed, and then moved upwards, repeating the process until the required height is reached. The formwork is then removed, leaving the wall to dry under the sun, and in some cases, the wall is finished with lime mortar. The first hospital in Santo Domingo, San Nicolás de Bari, was built on November 29, 1503. The construction was divided in three phases. From 1503 to 1519, when the construction began, some rooms were built. In 1519 to 1533, when the additional rooms were built and others were enlarged. From 1533 to 1552, when the enlargement were completed. The hospital was incorporated in 1541 to the Sancti Spiritus in Saxia, an order that provided care and assistance to pilgrims. In the 19th century, the building was abandoned, and in the mid-20th century, the front part was demolished. Therefore, the aim of this research is to characterize one of the first tapia walls that were built in the New World. In this case, the first walls of the Hospital San Nicolás de Bari, built between 1503 to 1552 in the city of Santo Domingo, Dominican Republic. Areas with different appearance were observed within the walls that were related to different composition of the mixture. For more detailed assessments of the properties of the tapias, four different areas were analyzed: TS&B with brick chips, TBS&B1 shells and clear sand, TBS&B2 with crushed bricks, and TBS&B3 with shells and sand. Two samples were taken from the ruins for the laboratory analysis, representing two different types of original materials used for the construction of the earth wall, as identified from the visual inspection. Sample TBS&B is from the tapia wall with one course of bricks to separate the formwork box from the other. The color of the mixture is yellow-gray, and bits of a white compound, probably lime, can be observed. Sample TS and B is from a tabular wall with two courses of bricks to separate one formwork box from the other. The color of the mix is ochre, and bits of bricks and a white compound can be observed. In situ and laboratory test, a visual analysis and a photographic record were carried out. The Munsell color system and a digital colorimeter were used to determine the color. Surface resistance was determined with a geohammer spectrometer in laboratories. Fourier transformed infrared spectroscopy, Raman spectroscopy, and differential thermal and thermal gravimetric analysis were applied. The hospital, San Nicolás de Bari, is built of tapia walls topped with bricks and coral stone. In the area of the church of San Nicolás, the arches and columns are made of coral stone, but nowadays there are only remains, and some ashlars and bossuors on the floor. In the walls, the arches and the lunettes of doors and windows are made of bricks. Tapia walls have different measurements. The first three layers are 91 centimeters high, and the other two that complete the first level are 84 centimeters high. In the second level, the layers are 82 centimeters high. The thickness of all of them is 110 centimeters. There are some crates that are 395 centimeters long and other that are 358 centimeters long. These differences depends on their location. Each section of the wall is separated horizontally by a line of bricks laid horizontally. The bricks are 14 centimeters long and 4 centimeters thick with a spacing of 2 to 1.75 centimeters between them. The boards forming the box were 16 centimeters high, and the pole supporting the box was placed every 48 centimeters. In this slide, the table presents the results of the in situ characterization of the walls. It is observed that the appearance in the center of the wall in TS and B is 7.5 YR 6 over 4. TBS and B1 is 7.5 YR 7 over 3. TBS and B2 is 7.5 YR 7 over 3, and TBS and B3 is 10 YR 8 over 2. Meanwhile, the graph shows the CLab coordinates obtained in all the points analyzed in the wall. Despite the dispersion in the results, it is clearly highlighted the higher value of the A coordinate of TS and B as compared to the other area coherent with the reddish tone of this area. TBS and B1 and TBS and B2 show similar values of the three color coordinates, and TBS and B3 show the lowest A and B values and the highest L values, which correspond to the lighter yellowish appearance of this area. The results obtained by the decolometer are consistent with those determined by the Munsell system. In the table, you can observe the results of the rebound value obtained by the geohammer. The average rebound value ranged from 26 to 42 according to the data supplied by the manufacturer of the instrument. These values correspond to a compressive strength between 112 and 47 MPa. It is observed that the two samples, including brick, have a higher compressive strength value than the samples, including shells and sand, so that the addition of brick was probably intended to provide a higher strength to the wall. In the case of Fourier transform infrared spectroscopy, the TSNB and TBSNB samples present a similar composition with different concentrations of the constituents. They have kaolinite presence of quartz, and calcium carbonate as calcite was identified from the bands at 1409, 872, and 712 centimeters minus 1. The presence of gypsum comes from the OH bands at 3538 and 3404 centimeters minus 1, as well as from the sulfate bands at 1164, 1114, 668, and 602 centimeters minus 1. The iron oxide is a hematite. In the TBSNB sample, the calcite is much higher than those of the other components, indicating the higher amount of lime as a binder and the higher amount of calcite, characterized by a white color, is consistent with the lighter color of this sample, possibly due to the marine shells. While the Raman spectroscopy, in the case of the TSNB sample, an iron oxide was identified in the TBSNB sample. Two types of aggregates were analyzed, one dark-colored and one light-colored. Quartz and gypsums were identified. Therefore, from the results, it can be deduced that the samples are lime mortar with aggregates of different nature, quartz and gypsum. In addition, sample TSNB shows pieces of ceramic materials and the presence of hematites. These results are consistent with those of visual and optical characterization. Kaolinite has a very low Raman scattering, with a small signal at 130 centimeters minus 1, so it is very difficult to identify this compound by this technique, and normally other components are more easily identified, even if they are in lower concentration, as is in the case of iron oxide. The DTA-TG results shows that in both samples there is a weight loss between 30 and 100 degrees Celsius due to the presence of hygroscopic water with a highly value in the case of TSBN in the range of 70 degrees and 130 degrees Celsius and 110 degrees and to 180 degrees Celsius. The weight loss is due to the water of crystallization of the dehydrated calcium sulfite, which takes place in two steps. Both hematite and kaolinite have been identified in TSNB and TBSNB, being the TSBN sample the one with the highest amount of both compounds, which could be associated to the red clays observed in the sample. These clays explain the darker and orange color of the sample and could have been used as an aggregate or a pozzolanic material. We can conclude that both tapial mixtures are based on lime and kaolinite type clay, the aggregate of quartz in both cases with small amount of gypsums in the sample TBSNB. Two different techniques were also identified, one with one quartz of bricks separating the formwork box from the other, with a yellow-gray mixtures and pieces of lime and lower compressive strength, and two with two courses of bricks separating the formwork box from the other, with an ochre mixture and pieces of bricks and lime with higher compressive strength. The composition results are coherent with the appearance of the materials quantified in terms of the CIELAB color coordinates. These data allowed us to relate the remains to their historical evolution and constitute essential information for the restoration of the analyzed monuments. According to the analysis with the geohammer, the resistance of the tapia is very good, with a difference between the one containing shells and sand and the one containing crushed bricks, the latter being more resistant. Thank you very much.